Back again, another lesson. Went from the jointer, we're going to take a short walk over to the table saw, always in that sequence. What you always want to do is make sure that when you joint an edge on your board, you come right over to the table saw. In other words, you want to make that sequence go from the jointer to the table saw so that you clean up your two edges first before you move over to the chop saw or the miter saw or the radial arm saw, where you'll square an end and then cut your piece to length. This was a board that I jointed. This is a very, very common question that's always asked to me. I went over to the jointer, I jointed this edge, I got a beautiful cleaned edge. The question becomes, well, Mr. Shimko, why can't you just come over here and joint this edge so that you have a cleaned edge and a cleaned edge over here? This is probably the most important question that's asked on the table saw, and it's one for you today. This edge has been jointed, it's machined. To get an edge parallel to this, I'm assuming that this edge is exactly even. And as you looked on your boards of hardwood, the one thing that you were told was that these trees and these cuts go as the tree runs. So there's no telling that this edge is parallel to this, especially after I joint the edge. There's only one machine in this shop that will make an edge parallel to a machined edge, and that's the table saw. The table saw is set up so that you have a fence and a blade parallel to each other. So if I take this jointed edge, put it up against the fence, I always put that edge up against there if I want to clean the opposite edge up. That will ensure that it's parallel. So the jointer, you're only going to joint one edge. How many edges do I joint on any board? The correct answer is one. You joint one edge, never two edges on the jointer. Once I have that machined edge, I can come over here, I can set the machined edge up against the fence, and I can rip this to whatever width I want it to be. Let's take a look at the boards that you're going to use. The boards that I cut over here always have to have a machined edge. The question is, can I use anything that's off the rack that's in the rough? No, because you're going to get a cut that's parallel to whatever you put up against there. A lot of those edges you look at and you go, well, this looks fairly close. Close is no cigar. When it comes to jointing an edge, it makes it true, it cleans it up, it allows you to come over to the table saw and cut it so that the opposite edge that you cut on the table saw is exactly parallel. I can't stress that enough. Let's look at the table saw by itself. Very similar to the jointer, the table saw has a fence, which indicates that you're supposed to be cutting straight lines on this. Whenever you're using your fence, that edge, the machined edge goes up against the fence and it'll clean up the opposite edge. So I have a fence, I have the table. This is by far and away the most popular machine in the shop. As a matter of fact, I would venture that many people who are at home probably have a machine similar to this. The table saw gets its name by the large table located directly in front of me. And anytime I refer to any of this, I'm referring to it as if you're the operator, you guys are me. So if I say to you, you're going to adjust the fence to the right of you, meaning that you are standing exactly where I am. The table saw size is determined by the diameter of the blade, which means whatever the distance is from table saw tooth to table saw tooth determines the size of the blade. Damn it. In our case, this is a 10-inch table saw. The blade is 10 inches across in diameter. Many people will say to me, my table saw isn't a 10-inch saw because the table's only this big. The table size does not determine the size of the table saw. It's determined by the diameter of the blade, so that's important. I happen to have a 10-inch table saw at home. The table's not nearly this size. I set this table up so that we can rip and cross-cut plywood. So that's the only reason why the fence is the size it is, that the table is the size that it is. This machine right here is determined by the diameter of the blade, and it's usually a question on a quiz that I give you. Other parts that you should know about. The blade, when I raise it up, is raised up by the crank wheel that's located in the front of the saw. Again, if you're me, it's located over here. Notice that there's a crank wheel on the front, directly where I'm standing. There's also a crank wheel on the left-hand side. This happens to be a tilting arbor blade, which means that the saw blade is set at 90 degrees, but if I wanted to, I could use the wheel on the left-hand side and actually angle it to 45 degrees. I don't want to do that right now. As best as I could, I set the angle of the table saw blade and the table to be exactly 90 degrees. That's where I want it to stay. So usually on the left-hand side, no one ever touches that adjustment. The adjustment that you're going to make is located directly in front of you when you're operating this. And if you look at this, the table saw blade is below the height of the table right now. What I want to do is I want to raise it up, but the question is, how high do I raise it? If I take the crank wheel and turn it, let's see, in which direction? I'm going to say it's clockwise, because that always means up and tighten. I'm going to turn it clockwise. I direct your attention to the blade, and you'll notice that the blade is raising up. My question to you is, how high should that blade be above the height of this board? This is absolutely unnecessary and super dangerous. I never want to keep the blade that high. Always between an 1/8 to a 1/16 of an inch above the surface of the wood. So if you notice, I'm turning it counterclockwise now, and I want it to go just above the surface of the board. I don't want to go below it, I want to go just above it. So right there, I've set the adjustment height of the saw blade. So that's half of the battle. The next question is, how wide do I want this board to be cut? Well, if I take my handy dandy tape measure and measure this board is a little bit more than 4 1/4. I want to cut to 4 inches wide. So what I'll do is I'll set the fence to 4 inches. And this is really important. If you look at this fence, which is really different than the ruler that I taught you, you will notice from 0 to 12, this fence has 1,000,000 little lines. As a matter of fact, it has 32 times 12, 320, 64. It has 384 lines there. I never showed you a ruler that had 384 lines. Reason for that? That measurement has been broken down into 32nds of an inch. I only taught you 1/16 of an inch. But 0 to 12 is broken down into 32nds because they want you to be more accurate if you need to be more accurate. From 12 to 54, the rest of this fence, it's broken down to 1/16 of an inch. 1/16, 1/8, quarters, half, and finally inches. So what you have to understand is when you're taking the measurement from 0 to 12, totally different than going 12 to anything past 12, up to 54. Our particular fence is a Biesmeyer fence, which allows you to slide the entire unit to the left or the right. On the right-hand side, there's a black sight glass here. So that line right there indicates my 4 inches. I want to set this to 4 inches, which was the width that I need my board to be cut. So if I take this bad boy, slide it over, excuse me, cameraman, right there, it looks pretty accurate at 4 inches. Now what I'm going to do is I'm going to lock the fence down. And what I want you to do is notice this fence as I lock it in place. Because if you notice when it locks, I don't know if you noticed it right there, but it moved. It moved to accommodate the 4 inches. It will self-align itself. So when I lock the fence down with this knob, right now this will not move. It's set at exactly 4 inches, and I'm all set to make my cut. This is huge, and this will be a question on your quiz. What piece of wood always goes in between the fence and the blade? And the answer is the piece that you want to keep. In other words, If this piece happened to be a piece of pine, and the pine board had 2 machined edges, and the distance between edge to edge is 7.5 inches, I want to keep 2 inches. So my question to you is, what do I set the fence to? The board, if I measure it, comes out to be 7.5. Do I set the fence to 2 and keep what's in between the fence and the blade, or do I set it to 5.5 and keep the 2 inches on the outside? Well, I already told you that the piece that you're keeping goes in between the fence and the blade. The question is, why? I look at a piece that has to be ripped to 2 inches. It's safer if I put it on the outside of the blade because I have more to push in between the fence and the blade. But the question is this piece going to be 2 inches like I want? If this piece is 5.5, the correct answer is no, it's not. And if you're thinking, you're looking at this saying, no, 5.5 and 2, 7.5, it works out perfect. What you're forgetting is this. That saw blade has a thickness to it. The thickness of this saw blade is about 1/8 of an inch, which means when we cut, we are actually going to lose 1/8 of an inch with every cut. The byproduct of any cut that you make in here is this sawdust. So when you're cutting, we're going to lose 1/8 of an inch because of sawdust. Remember, you're not cutting your wood with a freaking laser beam, okay? Okay? You are cutting with a saw blade, so there's waste. So the good piece that I keep should always go in between the fence and the blade. There might be an occasional time when that doesn't happen, but I will tell you. In our case right now, we want to keep 4. I'm setting the fence to exactly 4 inches. I'm going to lock the fence down. The blade is raised. I'm all set, ready to cut. When you guys cut, you're going to have the guard in place. You're going to be using either a push stick or a push block. It's up to you. But anytime you cut, I always want these fingers to stay these fingers. We don't want these fingers to become that finger, because if that happens, 9.5 is not nearly as good as 10. Always, safety matters. And this is the most dangerous piece of equipment that we have in the shop. It's used the most. It's not understood. Until you really understand this machine, you really need to focus on the basics, safety basics. Sleeves are rolled up, safety glasses are on, body position is going to be where I want it to be. And whenever you do this, there's always somebody watching you. I will be right here pulling your board out. Nobody ever works on the table saw by themselves. So if you want to get my attention, all you have to do is turn this machine on. I could be anywhere in this shop. If I hear this saw go on, it's going to be like the Jack Link beef jerky commercial. You turn the machine on and my head is going to go up like this, and I'll be running over. Nobody's ever cut on this by themselves. You are always supervised. If you're working by yourself at home, I would say you want to make sure that you understand this before you work on it. And I'll show you a couple of instances of that dangerous thing called kickback. Let's make our cut at 4 and we'll see how we do. Some things that you should know about this saw. And by the way, I'm going to put the guard down so you could see me cut. If you look at this saw blade, and I'll ask cameraman to come in closer, you will notice that this saw teeth on this particular saw are bent. In other words, there is the saw tooth that has a point over here. The other point is over here. This point is over here. This other point is here. If you look straight down, there is a slight bend to this saw. One is facing out, one is facing in, out, and so forth. The reason why that is such is because whenever you're cutting, if the saw blade was just a straight blade with teeth directly in back of each other, the board would tend to bind on the teeth. So when you think about this, the way they engineer this, and it's pretty amazing, the bandsaw, the jigsaw, a hacksaw, any saw that you have in the shop, the chop saw, every single saw blade will always have teeth bent from side to side. It's referred to as a saw set. So the teeth look like this. So when you send your board through, you're actually cutting something that's this big, even though the rest of the saw blade is only this big. So it's cutting it wider at the top than at the bottom, which allows the board to move through there without getting bound up. So every single saw blade that you ever see always has a set, and no one ever thinks about it. It's important because when you're cutting on the table saw, probably at your home, I don't think anybody's going to have a fence that looks like this. I know I certainly don't. So when I'm setting the fence on my table saw, I always use a tape measure, and I'll measure from the fence to a tooth that's facing in to be exactly 4 inches. That's the way I do it at home. And I'm sure you're going to do it the same exact way. So a couple of repeats. The piece that's good always goes in between the fence and the blade. You always want to make sure that you understand our fence setting. 0 to 12 is broken down into 30/2 of an inch. Whenever you're cutting, the blade should always be 1/8 to 1/16 of an inch above the work surface. The good piece always goes in between the fence and the blade. Let's stop fooling around, see if we can't make a cut. So with this all set, what I want to do is I'm going to put the machined edge up against the fence. In order to do this, I need to hold the board up against the fence. So I'm going to make an L with my left hand and place this on the outside edge. Notice my fingers are here, my thumb is on the surface holding it down. You cannot take your left hand and use it like a dead salmon. There is no way with the force of this saw blade that it's not going to pull off of the fence. So you have to physically do this. In order to do that, you also have to understand that this left hand is not going to move. It's not going, because if it's going, your thumb is gone. You always want to make sure that that left hand stays there and never ever moves. What I'm now going to do is use my right hand, because unfortunately this machine is meant for right-handed people. You could either grab the push stick, chortle, or the push block to push your board all the way through. Again, the guard is down so that you can actually see me make the cut. On this board, I'm going to use my push block. I'm all set, making sure that no one is around, and I can make my cut. I'm going to roll up my sleeves, exposing my massive pipes. Grab hold of the saw board, keeping in mind I should never do this. And I see this done 1,000 times. People start to rehearse it in their mind. Okay, set the fence, raise the blade. They start to push this in, and then all of a sudden they go, okay, all right, that's the way I'm going to do it. Now they reach over here and they turn the machine on. If that board is making contact with those teeth, this board is going to go flying. I saw it happen last year one time, and boy, was it an eye-opener. Please make sure that when you do this, you're holding onto your board. If you want to do that, slide it off to the side. You want to make sure that nothing is in the way so that when I'm cutting, nothing ever comes in contact with those teeth. Nobody's around, safety glasses, sleeves rolled up, lanyard in the back. I think I'm ready to go. Push stick, I don't need it. Push block, I do. I'm going to turn the machine on. Let's see. There's a green button and a red button. Which one would it be? Let me think. Oh, yeah, that's right. He said the thinking's the hard part. Yeah, green. Green, we're going to turn this bad boy on. So I'll take this, push it in. All set, ready to go. How fast is that saw spinning? Believe it or not, that is spinning at about 30,000 revolutions per minute. It is carbide steel. It's the hardest steel that's made. This particular tooth, if I turn it on and it goes around, it is going around at about 500 times in 1 second. So I turn it on, I count to 1, and that thing has gone around 500 times. What? You don't believe me? You calling me a liar? Oh, you are. I'll prove it to you. I'm going to count how many times that thing goes around in 1 second. What I'll do is I'll take my pencil and put a little pencil mark on this particular tooth. I'm going to count to see how many times that goes around in 1 second. Ready? 500, yep, 500. It was 500 times. 500 times in 1 second, which is unbelievable how fast that thing is spinning. By the way, folks, this wood is a heck of a lot harder than this skin. So if it cuts wood like butter, it's going to cut your finger even easier. So I can't impress upon you enough. These hands always stay here and on a push block and away from the blade. The good part about a push block is that it elevates my hand away. The good part about a push stick is a push stick really elevates my hand away unless I hold the push stick all the way down, which defeats the purpose of the push stick. So if I'm using a push stick, index finger, always right index finger on the top edge, which is going to elevate my hand about 8 inches above the blade, and that's where I want to be. When I do this, I'm going to take my push stick, not put it directly up against the fence, because if I do that, it usually pushes it off the fence. I don't want to keep it off to the side here because it'll usually come off in the back, about in the middle between the fence and the blade. Slight angle, slight angle towards the fence. As I push this thing through, my eyes are not on the blade. A lot of people go like this, oh wow, that's really cutting, wow, that, no. Your eyes should be glued to this fence, because if this sucker comes off the fence, you got some major problems. So what I want to do is make sure that this stays up against the fence as I cut. And as any wise person knows from the jointer, I'm going to take 1 step off to the left-hand side. I don't want to be directly in back of here. As I said, things line up, especially if you're a male and you're 6'1". So I want to take 1 step off to, I am not standing off here because I'm afraid. I want to make sure I'm standing here where the action is, so I'm not leaning over too far. I don't want to reach, I'm not moving back. I've seen people do this an awful lot where they're afraid of that machine, which I understand because fear is not knowing. After you make your first cut, I bet you're going to be a lot more relaxed with the second cut. But as far as the first cut goes, oftentimes people will do this, they'll push the board in and their butt moves back. And they keep going back and back until they're leaning over from this position. You want to make sure that you want to stand right here. You want to make sure that your feet are right up against it so you're not leaning exhaustingly over the blade. Let's make the cut. Take the board, push block, I turn the machine on. Machine edge up against the fence, don't make this move. Make sure the machine edge is up against the fence. Now with my left hand, holding the stock up against the fence. Push block smack dab in the middle, slight angle in towards the fence. And now I'm going to push the board underneath my left hand. When I get to this point here, I've run out of wood. There's no reason why my left hand has to stay there. So I'm going to drop my left hand. I can't tell you how many times people put their left hand here. And as they continue to push, a splitter might come up and it hits their hand and they go like this. And then they look at me like I did it. No, just take your left hand and drop it. I'm making sure that that's up against the fence as I continue to push it, all the way through the path of the blade. All the way, that's not all the way, that's all the way. I'll be over here to grab your board. I'm shutting it off, and I'm gonna lower the saw blade down even before it comes to a stop. The sooner I can get that blade down, the safer it is. So here was my machined edge. Here's my fence, my fence. Here's my board that is cut to exactly 4 inches. And this is a nice true edge that comes exactly parallel to that jointed edge. The one thing that I do want to show you, and this is very, very concerning. Let me see if I could find this here. Up. Here's a piece. Years ago, I gave this lesson to a bunch of 8th graders, the first time they were ready to make their cut. I finished my cut. The saw blade was still up. I passed the board through. And as the saw blade was spinning, the crowd said to me, take that piece out. And of course, the one thing we never ever do is play the got it game. I never want to reach in there just to get that out. With that in mind, I said, guys, you don't have to worry. That piece is going to go nowhere. You just saw me make a cut where the scrap piece went underneath the table. But sometimes this happens. If it's a really light piece, this piece might move with the vibration and the breeze from the saw blade, and there's an issue if this board should go like that. Right here on the front of these teeth, the saw blade is cutting. But on the back side, what's happening? The saw teeth are coming up and they're pushing whatever is here or in contact with the teeth up and back. So as I was cutting with my 8th grade group, I said to them, look guys, you don't have to worry because that board is going nowhere. It's on the outside. It's not wedged in between the fence and the blade where it's going to kick back. As soon as I finished that statement, this board moved, came back, made contact with the saw teeth, and shot back at me. As soon as it shot back, it hit me so hard, I fell to my knees, and I felt a real stomach ache, and I can't even describe it. And then I was trying to catch my breath, and I was going, and the kids thought I staged the whole thing. They're like, hey, great job, do it again. Hey, that's fun. Well, I didn't stage it. What I've learned is whatever is on the outside teeth of the blade, most of the time won't hurt you, but if you have that little bit of vibration and it touches the backside of these teeth, this board's coming back. So you always want to be aware of it. But you never want to play this game, which bothers me more than anything. Got it, yeah, all right, yeah, I got it, yes, I got it. Hey, all you have to do, dude, is lose one time. You lose one time, and that's what's gonna happen. So you always wanna make sure that whatever's on this side, I let it stay. I wait until the saw blade comes to a complete stop, and then I move it. Also, I wouldn't stand here and have a picnic. I would make sure I stay on the left-hand side because you never know when that board could shoot back. So here is my board, all set, ready to go, 4 inches wide. Now I have to worry about these ends because obviously this end doesn't look square. I'm gonna go over to the miter saw where I'm gonna square an end and cut it to length. But someone said to me, hey, Mr. Shimko, can't we do this here? Years ago, before that radial arm saw was ever invented, you probably have noticed something on the table saw, these 2 grooves. These 2 grooves are set up for this handy dandy little piece of equipment. If I ever want to cross cut on this machine and I have a narrow piece to cross cut, I always want to use this miter gauge. M-I-T-E-R, which means angle. Gauge is what's going to go in between these grooves on the table saw. The way this little ditty works is I'm going to take this little tool. If I move this, because I preset this to be exactly 90 degrees, I can take my board, which has 2 parallel edges, put it up against the miter gauge, use my left hand, hold it up against the miter gauge, and push this through the path of the blade. The miter gauge will take care of any angle. And it's the way this always was operated before the radial arm saw, miter saw, chop saw was invented. The problem with this is that the larger the board, the more difficult the job. In other words, if I am cutting this at a 90-degree angle, it really isn't a big issue because I can hold this pretty easily. But the wider the board becomes, the more it becomes an issue and the less accurate. This will be less accurate than a narrower board. And the board that I have over here, which I glued up for my wife's tabletop, this would be a real issue. The question is, how accurate can I be if I'm cross-cutting a piece 16 inches? Well, this thing is going to move, and there's play. So my suggestion is we don't use the miter gauge to cut or to square an end, but you use the miter saw when you're cutting. So we'll go over there, we'll square an end, we'll cut it to length, and we'll formalize a little lesson on that miter saw. So if there's any questions right now, all I've done was I've made a cut. It's the same cut you're going to use to cut your sides of your projects. If you're making a footstool, anytime anybody rips a piece, you're cutting along the grain. If I cross cut, I'm doing this operation. When I was cutting before, cutting along the grain, it's referred to as ripping. So I ripped this board to width after I jointed an edge. Then I'm going to go to the miter saw, square an end, and then I'll finally cut it to length, and this piece will be completely square. Okay? Let me take a look to see if I covered everything on my stink pad. Eye patch. iPad. Yep, we talked about the table, the guard, the fence. Yep. The blade, I mentioned about the saw set, the inside tooth, the outside tooth. I mentioned about the miter gauge. You would use that if you're cross-cutting. Ripping to width is what we did, the inside tooth, the outside tooth, and kickback. Let's talk about kickback, and I'll try to make this short and sweet. Kickback occurs anytime I make a cut and don't push what's in between the fence and the blade all the way through it. In other words, right now, this board is the perfect size to fit in there. It's making contact. It's getting a wedgie between the fence and this blade. If I wanted to shoot this back, all I have to do is turn this on. This is wedged in between the blade and the fence. It will shoot back here. So that's the reason why I told you when we were making our cut and you're pushing it, you want to go all the way, all the way, all the way, all the way, all the way through in order to clear that. So if I get halfway, let this thing go, it's coming back at me. That's one way kickback can occur. The second way, and the way that I learned kickback, had to do with a student of mine who was cutting a piece of plywood many years ago when I started. And when he was cutting a piece of wood, let's see if I can find something similar to what he was cutting. He was a really good student. It was my first full year teaching, so that was way back in 1981. And I never thought too much about people cutting on this saw by themselves. I was on the bandsaw just maybe 8 or 10 feet away. This good student came up to me. He said, "Mr. Shimko, can I cut this piece of plywood on the table saw?" And I said, "Sure, Kevin, no problem." So what he did was he set the fence to whatever measurement it had to be, and he started to cut. As he was cutting, he started the machine up, started to push this through the blade, and as he was pushing it through the blade, something happened. As he was pushing it, he noticed that it came off the fence. So he tried to keep it up against the fence, couldn't do a very good job of it. So he did one, simple thing. Took his left hand, instead of putting his left hand all the way over here, he took his left hand, put it in the front of the board. Number one, wrong thing. Because anything that's on that side of the saw sometimes comes back this way. So that's why I always try to tell you to keep your hands towards the front of the saw and never go in the back of the saw. Well, Kevin, being the good student that he was, started to cut. And I'm kind of watching him. Okay, he's doing a good job, no problem. Kevin's pushing, 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 pushing. And then all of a sudden he gets to this point. Kevin runs out of left arm. This is as far as his left arm can go. So now he still has to clear about 4 inches on that cut. How does he make his left arm longer? Well, he's not Gumby. He can't just take it and extend it. There's only one way that you could make your left arm longer. And this is what I've realized after many, many years of this experience. If I want to make my left arm longer, the only way I can do that is move my left arm closer to my left shoulder. If I do that, my left arm gets longer. As I go across, it gets shorter. So Kevin, when he was making his cut, got to this point, and the only way to make his left arm longer is to move it to his left and to bring it off of that fence. And that's when disaster struck. He moves it so the board comes off the fence, and instead of the front teeth cutting, the back teeth lift. So here's his hand. The back teeth make contact with the board, and it shoots it back, just like that. And his hand went directly over top of that blade. I was shocked. I looked up, and I see nothing but a wall of blood here. And I'm going, oh my goodness, what has happened to this poor child? I had first aid in college, which was a great course. I walked over, even though my heart was going like this, and I didn't know what Kevin had on his left hand. All I know was I saw blood coming down from his hand. I grabbed hold of his fingers, and just like they tell you in first aid, elevate it and let's go get help. So we walked out of the shop to the nurse's office, and the whole time I'm thinking to myself, oh God, please let this kid still have a hand. We get to the nurse's office, and Kevin is fine. Okay, it hurts a little bit. But the nurse says, okay, now you have to let me see what's there and what's not there. I open up my hand, and I'm expecting fingers to just drop out. And by the grace of God, and like I said, by the grace of God, I let his finger and his hands go. Everything stayed on. And he did require stitches because it went directly over top of the saw blade. The one saving grace is that if you look at the saw blade, it's not raised up really high when he was cutting a piece of 1/4-inch plywood. When that happened, it was a real eye-opener to me, and certainly something that I looked at and took another look at in terms of everything that I did in the shop. Now I try to make sure that everybody is supervised, everybody's more aware of instances that could happen. When you're cutting and you're making these cuts, always make sure that your body position is off to the left-hand side. Always try to make sure that you're aware of what could happen. Another instance of kickback that I do want to show you has to do with the miter gauge. And when we're cutting with the miter gauge, you never want to do it in conjunction with the fence if the miter gauge does not fit in between the fence and the blade. In other words, if I'm making this cut, that's okay and safe because the piece in between the fence and the blade is not getting a wedgie. It's not wedged in between the fence and the blade. Something as simple as this adjustment over here. If I take the fence, move it so that the end of the board is up against the fence and I make my cut, will cause this piece to become a projectile. So you want to take this and always make sure that it's not wedged in between the fence and the blade. However, it is okay to do that if the miter gauge is placed in between the fence and the blade and you're cutting this way because you're pushing what's in between the fence and the blade all the way through. So to review and for you to understand, if I take this board, place it like this, will it kick back? The correct answer is no, because it's not wedged in between the fence and the blade. If I take it, place the fence here, put the board up against, as many people do, If I need to cut a piece to be 6.5 inches, I'm going to cut 3 pieces 6.5 inches. People think they could set the fence to this measurement, make a cut, slide it over, no, 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 no. Because this board will definitely kick back. It's wedged in between the fence and the blade. So if I have to make a cut at 6.5, the smarter thing would be to go to the miter saw, set up a stop on the miter saw and cut it there. That way I'm not wedged in between anything and you're holding what's in between the fence and the blade. So it's huge that you understand this concept of kickback. Another thing you never, ever, ever in a million years want to do is to make a cut like this. If I lock this down and this board is so narrow and this board is moving from side to side, this piece is going to come back at you like nobody's business. So I never want to cut without a miter gauge if I have a narrow piece. If you have a wide board and you have a squared end, nope, not a squared end, not a squared end, forget about that one. Yup, a squared end. If I take this piece, can I safely make this cut and push it all the way through between the fence and the blade? Yes, I can. So a lot has to do with how wide the board is. The more surface area it makes contact with on the fence, the better for you. You can push it this way. So I can take this fence, even if I can't put the miter gauge in between the fence and the blade, a lot of times I can use my fingers and my hands as the human miter gauge and make sure I just push it all the way through. So that's where I say you have to understand what this machine is capable of doing and how to operate it. And there's no rules with this. So much of it is, oh, I understand exactly what I'm doing, why it's happening. That's the most important thing that you want to keep in mind whenever you're working on a machine like this. This machine has the capability of severing you, mauling you, killing you. You never ever want to take a chance with your health. So if you understand this, this could be the greatest machine that you have and that you operate. It could be the most amount of fun. You can make crazy things like this raised panel on this machine with that saw blade. People look at this and go, how the heck did you make it? That'll be another video for a different day. This could be the most helpful machine you ever use, or it could be the most dangerous death sentence you'll ever be encountered with. So keep that in mind when you're cutting. Always operate the machine safely. Always ask for supervision. Good luck with your cuts. And like I said, after the first cut, it all becomes a lot more fun. Stay safe, work on your project, and always use your head.